Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. Okay, as usual, we first come to its statement. Okay, a hydrogen atom electron. A hydrogen atom electron is in the 6f state. Part A, what are the values of N and L? Part B, compute the energy of the electron. Part C, compute the magnitude of L. Part D, compute the possible values of LZ, where Z is written as a subscript of L in this situation. Okay. Dear students, before solving this problem in a regular manner, we first introduce a few snapshots which will help us in solving this problem. Okay, which will serve as a foundation regarding the solution of this problem. Okay, so first snapshot is quantum numbers of an atomic electron. Okay, name, symbol, possible values, quantity determined. Name, principal quantum number, magnetic principal quantum number n, orbital quantum number L, magnetic quantum number ml, where L is written as a subscript of m, and spin magnetic ms, where s is written as a subscript of m. Okay, then atomic shells, n equal to 1 2 3 4 5 and below n equal to 1 capital K, then below capital then below 2 capital L, then below 3 capital N, then below 4 capital N, below 5 capital O, and so on. Okay, then angular momentum states L equal to from 0 to 1 2 3 5 4 5 and so on, while subshells S P D F G H and so on. Okay, we will follow such a guideline. Second snapshot is spectroscopic notation for atomic shells and subshells. This is all. students, this is second snapshot. Okay, spectroscopic notation for atomic shells and subshells. Okay, on left column n 1 2 3 4 5 6 and so on. Okay, and second column shell symbol KLMNOP. Okay, on right column first small l from 0 to 5, 0 1 2 3 4 5 and so on, while shell symbol are given as SPDFGH. Okay, 1 to 6 KLMNOP and from 0 to 5 SPDFGH. Okay, this is almost this arrangement is also given in the previous snapshot. Okay, so it may be said, it may be assumed as a little overlapping, but this little overlapping is not inappropriate, because situation is more has been made more clear due to this second snapshot. Okay, now third snapshot, energy levels of hydrogen En is equal to minus mr e raised to the power 4 over 4 pi epsilon naught whole square into 2n square into h cut square. Okay, where En is the energy levels of hydrogen, while 4 pi epsilon naught is the electric constant. Okay, while mr is the reduced mass, E is the magnitude of electron charge, N is the principal quantum number, and h cut or h bar or h reduced is Planck's constant divided by 2 pi, and this expression alternatively becomes equal to minus 13.60 electron volt over n square. Next snapshot is about electron angular momentum. Okay, capital L is equal to under root into small l plus 1 into h cut or h bar or h reduced. Okay, here h cut or h bar or h reduced is outside the under root atmosphere. Okay, with the orbital quantum number L restricted to the values L equal to 0 1 2 3 4 5 and so on up to n minus 1. Okay, so L varies from 0 to n minus 1. Okay, next snapshot is about space quantization Lz, where z is written as a subscript of L. Lz is equal to ml h cut or h bar or h reduced. Okay, ml here L is written as a subscript of m. Okay, while h cut or h bar or h reduced is Planck's constant divided by 2 pi. Okay, here ml is equal to 0 plus minus 1 plus minus 2 and so on up to plus minus L. Okay, in next snapshot, allowed values of quantum numbers for one electron wave function are given. Okay, here n, that is principal quantum number, n is either equal to or greater than 1. Okay, next orbital quantum number L is either equal or less than n minus 1, where n is the principal quantum number, or on other hand L is equal or greater than 0. Okay, L is either equal or less than n minus 1 and either equal or greater than 0. Okay, next orbital magnetic quantum number ml, where L is written as a subscript of m. Its modulus value or absolute value or magnitude is equal or less than small l, where L is the orbital quantum number. Okay, L is the orbital quantum number while ml is the orbital magnetic quantum number. Okay, orbital quantum number is L while orbital magnetic quantum number is ml, where L is written as the subscript of m. Okay, next is spin magnetic quantum number ms, where s is written as a subscript of m and it has only two values, that is either plus half or minus half. Okay, now we come towards the solution of the problem in a proper manner. Okay, part A. In 6F state, 6 stands for n. Okay, in 6F state, n is equal to 6 and L is equal to 3. From where we have found this, we go to snapshot. Okay, n is equal to 6, L equal to 3. N equal to 6, n equal to 6, n equal to 6, L equal to 5. N equal to 6, L equal to 3. N equal to 6, here dear students, this actually here n is equal to 6, L equal to 3. N equal to 6, L equal to 3. N equal to 6, L equal to 3. N equal to 6, L equal to 3. We find from where this 3 has come. Okay. N equal to 6, a hydrogen atom electron is in the 6F state. What are the values of N and L? Here N is 6 and F is 3. Oh yes. And matter solved, dear students. Okay, yes. When F is equal to when this situation is applicable. Okay, angular momentum states L equal to 0, 1, 2, 3, 4, 5. Then when L equal to 0, S. When L equal to 1, P. When L equal to 2, D. And when L equal to 3, F. We are given 6F. So here in 6F, 6 is N, while L is this 3, which is written above F. Okay, angular momentum states L equal to 0, 1, 2, 3, 4, 5, and below these values of L, subshells are written as S, P, D, F, and we see that F is written below 3, that is L equal to 3. When in NF state, N is equal to 6 and F is equal to 3 and L is equal to 3. Okay, because F is below 3 and 3 is L. Okay, so part A has been solved. Now part B, En is equal to minus 13.60 electron volt over N square. We move back to this. This snapshot has been followed. Okay, En is equal to minus 13.60 electron volt over N square. Here we will put N equal to 6, because in part A it is said that N equal to 6 and L equal to 3. Okay, When n equal to 6 will be put, then in the denominator we will get 36, and when 13.60 divided by 36, we get E6 equal to minus 0.38 electron volt. Okay, so part B has also been solved. Now we come towards part C. Part C, as small l is equal to 3, then this implies that L or L vector modulus value or a magnitude or absolute value is equal to L into L plus 1 H cut or H bar or H reduced, and this becomes equal to 3 into 4 H cut. This becomes equal to 12 H cut. Okay, dear students, here a minor mistake has developed, that here along with 12 under root H cut should be present, but by mistake this H cut has been omitted from here, and this alternatively becomes equal to 2 into 3 under root into H cut, because 12 can be written as 4 into 3, and 4 is equal to 2 square. So from 2 square, simple 2 can be taken out. Okay, now we come to that snapshot from where this formula has been used, that L or L vector magnitude equal to L into L plus 1 into H cut. Now we move to this is the value. Okay, this electron angular momentum L is equal to L into L plus 1 H cut. Okay, capital L is equal to under root L into capital L is equal to under root small l into small l plus 1 into H cut or H bar or H reduced. Okay, where H cut or H bar or H reduced is Planck's constant divided by 2 pi. Okay, so using that formula we have found the value of L, which has become equal to 2 into 3 under root into H cut. Now we come towards the part D. Okay, in order to solve part D, first we have to find M. Okay, for L equal to 3, as this portion has been selected from snapshot. Okay, this is basic formula, okay, for determining M. Okay, sometimes it is expressed by simply M, and sometimes small l is written as a subscript of M. Okay, there is no difference between these two notations. Some writers, some authors use simply M, and some authors use small l as a subscript of M. Okay, so small l is either equal or less than L, or simply M magnitude is equal or less than L. This implies that when L is equal to 3, then ML becomes equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, dear students, in mathematics, particularly in analysis and particularly in real analysis, this situation is very often faced. Okay, if this expression, that is small l is equal or greater than magnitude of M, can be written as small l is equal or greater than simply M without these 2 bars. Okay, small l is equal or greater than small m, and small m is equal or greater than minus l. So here small m becomes in between plus l and minus l. Okay, so value of when l is equal to 3, m will be n will be of such nature that it will expand from minus 3 to plus 3, and 0 will fall in center of it. Okay, as I have said that small l is either equal or greater than small m, and then small m is either equal or greater than minus L. Okay, this is a mathematics philosophy. So in other words, magnitude of M is in between plus L and minus L. Okay. So when L is equal to 3, it means magnitude of M is from minus 3 to plus 3 or from plus 3 to minus 3, and we see that after plus 3 there is plus 2, then plus 1, then 0, then minus 1, minus 2, minus 3, or if we move reversely, then first minus 3, then minus 2, then minus 1, then 0, then plus 1, then plus 2, then plus 3. Okay, so this is the value of ML will be equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, now we come towards LZ equal to MLH cut or H bar or H reduced. Okay, this snapshot in which space quantization LZ, where Z is written as a subscript of L, is equal to MLH cut, where small l is written as a subscript of M, and H cut or H bar or H reduced is Planck's constant divided by 2 pi. Here ML is equal to 0, plus minus L, plus minus 1, plus minus 2, plus minus 3, and so on up to plus minus L. Okay, so when L equal to 3, we are dealing with this. LZ is equal to MLH cut, and we have found the value of ML in this step. So we here with ML we will write H cut with each value. Okay, so LZ will become equal to this minus 3 will be written along with H cut or H bar or H reduced. Similarly, this minus 2 will be written along with H cut or H bar or H reduced. Similarly will be case with minus 1, then 0. With 0, H cut or H bar or H reduced is not appropriate. Okay, because 0 is 0. Whichever quantity is multiplied with 0, it becomes 0. Okay, so similarly is the case with these extreme right 3 values, that is 1 H cut, 2 H cut, and 3 H cut. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.